Welcome to the deep dive. We've got a really fascinating and I have to say quite complex set of sources today. They're all focused on Pakistan's coastline. It's this place that seems to be, well, pulling in two directions at once, a vital economic lifeline for the country, but also an ecosystem under enormous stress.
That's a perfect way to put it. A real study in contrast. We're looking at, what, almost 1,000 kilometers of shoreline? 990 kilometers, to be precise.
990 kilometers.
And it's not evenly distributed. You've got the Sindh province in the southeast with about 270 kilometers, and then the vast majority, 720 kilometers, belongs to Balochistan.
So our mission today really is to unpack that. How does this huge natural asset, this coastline, fuel the economy while at the same time facing these escalating crises? We're talking pollution, climate change, the whole works.
Exactly. That's the core dilemma, what you called the coastal paradox. And before we even get into the details of the coast itself, the sources emphasize the sheer scale of Pakistan's maritime reach. It goes way beyond just the shoreline.
Ah, yes, the maritime zones. These defined control resource rights. And they've actually grown recently, haven't they?
Significantly. So starting from the land, you have the standard territorial waters going out 12 nautical miles. That's pretty standard. But the real kicker is the exclusive economic zone, the EEZ.
Okay.
Originally, that was already a massive area, 240,000 square kilometers out in the Arabian Sea.
It's a huge area.
Huge. But then, using international law, specifically Article 76 of UNCLOS, the UN Convention on the Law of the Sea Pakistan put forward a claim based on its continental shelf.
And that claim was successful.
It was recognized, and it added an enormous 50,000 square kilometers to the EEZ. So now we're talking about a maritime jurisdiction that stretches potentially up to 350 nautical miles offshore.
Wow. And that gives Pakistan sovereign rights over everything, that water column and seabed, right?
Right.
Resources exploration.
Pretty much all living and non-living resources within that expanded zone. It's a vast underwater territory, really.
So, okay, we have this enormous, potentially resource-rich area. But, as we said, the very things that make it valuable, the shipping lanes, the industry buzzing around the ports, the fishing fleets, they're also putting immense pressure on it. That's the conflict.
It's the perfect storm, isn't it? Development versus conservation playing out right there. On one side, you've got these huge strategic projects like CPEC, the China-Pakistan Economic Corridor, massive industrial estates.
The economic engines.
Right. And on the other side, you have these incredibly fragile ecosystems. You know, the mangrove forests that act like a natural shield for the coast, fish stocks that are dwindling fast, and nesting sites for sea turtles that are globally important.
And it sounds like these problems are all tangled up together. Pollution affects the fish, climate change impacts the mangroves, coastal construction causes erosion.
They're completely interlocked. So yeah, our dive today needs to follow that structure. First, let's look at the geography, the physical layout, and those economic hubs, the ports. Then we'll explore the unique ecology and biodiversity. After that, we really need to get into the tough stuff, the unsustainable practices, the pollution, the fishing crisis, and finally we'll look at what needs to be done, this idea of integrated coastal management.
Okay, let's kick things off with the geographical foundations. Two distinct coastlines, Sindh and Balochistan. Tell us about the Sindh coast first, in the southeast. What defines it?
Well, the Sindh coast is really dominated by one massive geographical feature, the Indus Delta Creek system.
Ah, the delta.
Yes. Imagine this sprawling network of interconnected tidal channels, little islands, marshy areas, all formed over thousands of years by the sediment carried down by the Indus River. It's the lifeblood of that part of the coast. Its whole character comes from the river delta.
And within Sindh, there's a particular stretch that's incredibly important economically, the Karachi coast.
Absolutely. It's about 100 kilometers long, and it's just packed with significance. This is where you find the country's main industrial areas, the busiest ports we'll talk about, and also, popular beaches like Hawke's Bay and Clifton. It's where this massive city, Karachi, meets the sea.
Right. Urban density right up against the ocean. Then, if you head west, past the Hub River, which forms the boundary, you hit the Balochistan coast, also called the Mangroves coast. And it's totally different, isn't it?
Completely different world. This is the huge chunk, 770 kilometers. It's hyper-arid, very sparsely populated compared to Sindh. It's rugged terrain, geologically really active.
Active, how so?
Well, you've got the Makran Coast mountain range running along it, and it's crisscrossed with active fault lines. So tectonically, it's a dynamic area. Geographically, it's known for these large, deep, natural bays, places like Rotar Bay and Samiani Bay. These are naturally good spots for developing ports.
And there's an island out there, too, Astala Island. You mentioned it briefly.
Yes, Astala, or Haft Talar, as it's known locally, meaning 7 hills. It's a small, uninhabited island, about 20 nautical miles. That's roughly 39 kilometers off the coast from the town of Pasni.
Uninhabited makes it interesting ecologically, I imagine.
Critically important. Because it's isolated and relatively undisturbed, it becomes a haven, a kind of sanctuary for marine life. We'll definitely circle back to Astala when we discuss biodiversity.
Okay, so that's the geography. Now let's zoom in on those economic engines, the major seaports. Karachi Port, KPT. It sounds like the giant here.
Oh, it's the behemoth, no question. KPT is not just Pakistan's busiest, it's one of South Asia's busiest ports. The numbers are pretty staggering. It handles something like 70% of Pakistan's entire cargo volume.
70%.
Yeah, roughly 25 million tons of cargo every year. It's got a deep approach channel about 11 kilometers long, so it can handle reasonably large ships, up to 75,000 DWT deadweight tons, but it's constantly struggling with capacity.
That struggle, the congestion the sources mentioned, that must have real economic consequences, right?
Yeah.
It can't just be inconvenient.
It's a huge economic drag. Congestion means delays. Delays mean ships wait longer, turnaround time increases, and that translates directly into higher costs for both imports and exports. It's like a hidden tax on trade. When 70% of your nation's goods, including vital raw materials, are getting stuck in one place, well, those inefficiencies ripple through the entire economy.
Which I suppose is why Port Qasim, PQA, was developed, to take some of that pressure off Karachi.
Exactly. PQA was essential. It handles the other, roughly 35% of the national cargo. It's located about 35 kilometers east of Karachi, strategically situated on an old channel of the Indus River, which gives it good access.
And PQA is more than just a general cargo port, isn't it? It seems linked to specific industries.
Very much so. It was designed almost as an industrial hub in itself. It hosts the enormous Pakistan Steel Mills Complex, PSM, and crucially, something like 80% of Pakistan's entire automotive industry is clustered around Port Qasim.
80%.
Yeah, so between KPT and PQA, you're looking at over 90%, probably closer to 95%, of all of Pakistan's external maritime trade flowing through that relatively small stretch of the Sindh coast. It just underscores the dependence.
Then we have the third major player, Gwadar Port in Balochistan. This one feels different. It's less about current volume and more about potential, strategy.
Gwadar is the big geopolitical play. Its location is just remarkable. Right at the mouth of the Gulf, practically opposite the Strait of Hormuz, the world's busiest oil transit choke point.
So the CPEC connection is key here.
It's central. The whole vision laid out within the CPEC framework is to transform Gwadar from what was a small fishing harbor into a major regional hub for trade and transit. The idea is to create a new, efficient route, bypassing older, more congested paths.
Targeting traffic from the Middle East and the Gulf, presumably, maybe even Central Asia via China.
Precisely. The goal is to capture that regional traffic, potentially positioning Gwadar as a competitor to established hubs like Dubai or maybe even Iran's Bandar Abbas.
And they're trying to encourage that. How?
Well, it's been declared a duty-free port and a free economic zone that's designed to streamline logistics, make it faster and cheaper to move goods, especially between Western China, Central Asia, and the Gulf states. It's not just about Pakistan. It's envisioned as a gateway that could really reshape the economic geography of the whole region.
Okay, let's pivot now from the economy to the environment, the unique natural features. And we have to start with the heart of the Sindh coast, the Indus Delta. The sources call it the world's 6th largest delta. That's immense, 600,000 hectares. But it's also described as being under profound stress.
It is. Profoundly stressed is accurate. Historically, this massive delta was built and sustained by the enormous freshwater flows from the Indus River, carrying silt, nutrients, basically life. But over the decades, huge amounts of that river water have been diverted upstream, mostly for large-scale irrigation projects and hydropower dams.
So the delta is essentially starved of fresh water.
Starved is the right word. The flow has been drastically reduced, and that kicks off a whole cascade of problems, ecological collapse, really.
And it's not just the lack of fresh water, is it? There's something else compounding the problem. This left bank outfall drain, the LBOD. What exactly is that?
The LBOD. It's a classic case of a large-scale engineering project with devastating unintended consequences. It was built back in the 80s and 90s primarily to deal with waterlogging and high salinity in agricultural lands further inland in Sindh.
Okay, so the idea was to drain away the salty waterlogged
Yeah.
stuff.
Exactly. Drain away that highly saline, often chemical-laden agricultural runoff water to theoretically reclaim farmland. The massive problem is where they decided to drain it. It discharges directly into the eastern part of the Indus Delta near the border with India.
Wait, so instead of getting the fresh water it needs, the delta is getting a constant flow of toxic, salty wastewater.
That's precisely it. Continuous discharge. And the salinity levels of this effluent are incredibly high. The sources mention readings up to 30 millisiemens per centimeter, which is extremely saline. This constant poisoning is destroying the delicate balance of fresh and salt water that the delta's ecosystems, especially the mangroves we'll talk about, absolutely depend on.
The impact sounds catastrophic, not just ecologically, but for the people living there.
It's staggering. This saline intrusion, this creeping salt, hasn't just stayed at the coast. It has pushed inland, reportedly up to 150 kilometers in some areas.
150 kilometers.
Think about that distance. It's rendered vast areas of previously fertile land completely unusable for farming. The figure mentioned is 567,000 hectares. And the human cost. The sources estimate that nearly 1 million people have been forced to abandon their homes, their traditional livelihoods, and migrate. It's a massive ongoing displacement driven by an ecological disaster partly engineered by this drainage scheme.
That really crystallizes the coastal paradox, doesn't it?
Yeah.
A project meant to save agricultural land ends up destroying a vital ecosystem and displacing huge numbers of people.
It connects flawed development policy directly to human survival and environmental ruin.
Okay, moving eastwards geographically, we encounter the Rann of Kutch. It's described as this unique zone where the coastal environment sort of blends into the desert.
Yeah, the Rann of Kutch is fascinating. It's technically part of the Great Thar Desert, and it represents the very eastern end of that massive desert belt stretching all the way from the Sahara across Afro-Asia. It's a huge area, over 500,000 hectares, kind of semi-arid salt marsh.
And it's protected.
Yes, thankfully. It was declared a wildlife sanctuary back in 1980, and it's vital habitat, particularly for species that are threatened both locally and globally.
Like what kind of species?
Well, it's one of the last refuges for the endangered Asiatic wild ass, which is pretty much only found there now. Also, birds like the great Indian bustard and the sarus crane rely on this unique marsh desert transition zone. Its protection is key because it connects the desert wildlife with the coastal food webs.
Let's look at some specific islands now. We mentioned Astala or Haftalar earlier. What makes it so ecologically important?
Astala's significance really comes from its isolation and the fact that it's uninhabited by humans. Being 39 kilometers offshore from Pasni gives it that buffer. Its sandy beaches are absolutely critical nesting grounds for sea turtles.
Which species, specifically?
Primarily the endangered green sea turtle, which nests there in significant numbers, and also the critically endangered hawksbill turtle. Providing safe nesting sites away from human disturbance is crucial for their survival.
And didn't the sources mention something unique found only on Astala, an endemic species?
That's right. There's the Astala saw-scaled viper, Echis carinatus astalae. It's a small, venomous snake, a subspecies found nowhere else in the world but on this one little island. It really highlights how isolation drives unique evolutionary paths, even on small coastal islands.
Okay, closer to the metropolis, west of Karachi, there's the Chernakayo Island complex. What's special about this area, especially given its proximity to all that industry and shipping?
Chernakayo is known, perhaps surprisingly, for its high marine biodiversity. Despite being near Karachi, it supports quite diverse coral patches, not full reefs, but assemblages of different coral species. And maybe more importantly, it's a key area for marine megafauna.
Megafauna, like whales.
Exactly. Large filter feeders like baleen whales and even whale sharks are known to use the waters around Cherna as feeding and basking areas. The currents likely bring in nutrients.
But that location must make it incredibly vulnerable.
Extremely. It's right near major shipping lanes, fishing grounds, and potentially pollution sources from Karachi and nearby shipbreaking yards. That's why there's a push from conservation groups to get it properly protected, maybe designated as a no-take zone, to safeguard these critical functions for large marine animals.
We should also touch on those unusual geological features along the Makran coast, the mud volcanoes.
Ah, yes, the mud volcanoes. There are about 18 of them documented along the Balochistan coast. They're not volcanic in the lava sense. They're formed by pressurized gas and mud escaping from deep underground, often linked to the tectonic activity in the region.
And one of them has cultural significance, too.
Yes, the most famous one, Chandargup. It's actually a sacred pilgrimage site for the local Hindu community. They believe it's connected to the deity Bapaknath. So you have this fascinating intersection of active geology and ancient cultural practice right there on the coast. It shows the layers of significance this landscape holds.
And just briefly, the archaeology confirms this coast has been a center of human activity for a very long time.
Absolutely. Sites like Bambor are really important. It was occupied from maybe the 1st century BC right up to the 13th century AD. It was a significant medieval port city. And fascinatingly, the ruins include what's believed to be one of the earliest mosques built in the entire South Asian region, dating back to around 727 AD.
Wow.
Yeah, it really underscores that deep, long-standing connection between the people of this region and the sea for trade, for culture, for survival. You also find other remnants like Rann of Kutch Fort pointing to the strategic military importance of the coast through history.
Right, let's move on to a really critical ecosystem component,
Yeah.
the mangrove forests. You describe the Indus Delta as the heart. Maybe the mangroves are the coastline's protective skin, its shield. What exactly are they, and how do they manage to thrive in such a tough environment?
Mangroves are truly extraordinary plants. They're basically trees and shrubs, known as halophytes, that have adapted to live in salty, waterlogged conditions in sheltered coastal areas, think river mouths, estuaries, lagoons. And they're not just surviving, they form one of the most productive ecosystems on the entire planet.
Productive in what way?
They provide crucial habitat and nursery grounds for countless marine species, fish, shrimp, crabs. They trap sediment, stabilize shorelines, and act as a natural barrier against storm surges and erosion. Their economic and ecological value is immense.
Okay, let's get into the biology, because living with your roots constantly soaked in saltwater mud requires some serious tricks. What are their key adaptations?
They've evolved some amazing mechanisms. First, to cope with the soft, unstable mud, many species develop these complex root systems. You see long, arching prop roots or stilt roots
Yeah.
that spread out wide for stability and also help trap sediment, building up the land over time.
Okay, roots for stability. What about breathing? The mud must be low in oxygen.
Exactly. The soil is anaerobic, meaning oxygen poor. So many mangroves have developed specialized roots called pneumatophores. These are like snorkels. They grow vertically upwards, sticking out of the mud and water, and they have pores that allow the root system to absorb oxygen directly from the air.
Breathing roots. That's
Yeah.
clever. And how do they handle all the salt?
That's the third major adaptation. They have different strategies. Some species have ultrafiltration systems in their roots that simply exclude most of the salt from entering the plant. Others take up the salty water, but then excrete the excess salt through special glands on their leaves. Sometimes you can actually see tiny salt crystals on the leaf surface.
Incredible. And their way of reproducing is also special, isn't it? Vivipary.
Yes, vivipary is fascinating and crucial for survival in that tidal environment. It means the seed doesn't just drop off the tree, it actually germinates while still attached to the parent plant.
So the seedling starts growing on the tree.
Precisely. It develops into a sturdy, often long and pointed seedling called a propagule. By the time it detaches, it's essentially a pre-planted sapling ready to stick into the mud when it lands or float to a suitable spot and root quickly before the tides wash it away. It gives the next generation a much better chance.
Okay, turning to Pakistan specifically. The vast majority of mangroves are in the Indus Delta, right? What's their current status?
That's right. About 97% of Pakistan's total mangrove cover is concentrated within the Indus Delta system. Historically, it was a richer, more diverse mangrove ecosystem, supporting maybe 8 different mangrove species.
But not anymore.
Sadly, no. Primarily due to that increasing salinity we discussed, driven by the reduced freshwater flow from the Indus, 4 of those original 8 species are now considered locally extinct within the delta.
And that leaves one species dominating.
Yes, Avicennia marina, often called the gray mangrove. It happens to be extremely tolerant of high salinity conditions, much more so than some of the other species. As a result, it now makes up something like 90% of the total mangrove cover. While the sources indicate the total area might still be around 107,000 hectares in the delta, that lack of species diversity is a major red flag. It signals an ecosystem under significant stress, becoming simplified and potentially less resilient.
And the number one driver of this degradation is that freshwater scarcity we keep coming back to, linked to the dams upstream and the LBOD pollution. Is there an estimate of how much fresh water the mangroves actually need?
There is. The IUCN, the International Union for Conservation of Nature, has estimated that for mangroves to remain healthy, maintain growth, and allow for sediment balance, they need roughly 1 cusec, that's 1 cubic foot per second of freshwater flow for every 40 hectares of mangrove area.
Okay.
When upstream diversions choke off the river's flow, especially during critical periods, that basic ecological requirement just isn't met. Salinity shoots up, sediment supply dwindles, and the whole system degrades.
Beyond the water issue, are there direct human pressures on the remaining mangroves?
Oh, definitely. There's ongoing harvesting. People cut mangroves for fuel wood, for building materials, sometimes for fodder. While there are regulations, enforcement in remote delta areas is difficult.
And one surprising pressure mentioned is camels.
Yes, animal browsing, particularly by camels, is highlighted as a significant problem. Camels are often grazed in or near the mangrove areas, and they seem to particularly like eating the young mangrove seedlings and saplings. This browsing pressure can be extremely damaging to natural regeneration efforts, preventing the forest from recovering or expanding.
It sounds quite bleak, but the sources also highlight some major conservation successes. It seems like restoration is possible.
Absolutely. It's not all doom and gloom. Since the mid-1980s, there have been really significant, large-scale efforts to replant and rehabilitate degraded mangrove areas. The figures suggest around 80,000 hectares have been successfully restored through active planting.
That's a huge area.
It is, and it shows commitment. There was even that Guinness World Record attempt mentioned in 2013, where the Sindh Forest Department and local communities planted the highest number of mangrove saplings in a single day, a team of 300 community planters involved. It highlights the potential when resources and community participation align.
What are the main techniques used for this restoration work? How do they actually replant mangroves on that scale?
There are a few main methods. The most common and apparently the most successful in the Pakistan context is direct sowing. This basically involves collecting those mature propagules, the germinated seedlings we talked about from healthy trees, and then directly planting them into suitable mudflats during the right tidal conditions.
Just sticking them in the mud.
Essentially, yes, at the correct density and elevation. They also use nursery stock. This means establishing mangrove nurseries, often near the planting sites, where seedlings are grown under controlled conditions until they're strong enough to be transplanted.
Yeah.
And the third method mentioned is using wildings. This involves carefully collecting naturally germinated young saplings, maybe just 1 or 2 months old, from areas where they're dense and transplanting them to degraded areas where natural regeneration isn't happening. So it's a combination of techniques, but that continuous active restoration is vital, especially considering the role mangroves play in coastal defense against storms, which seem to be getting stronger and more frequent.
Okay, let's shift our focus from the shoreline forests out into the open water marine biodiversity, starting with the big animals, the cetaceans, whales, dolphins, porpoises. Pakistan's waters seem quite important for them.
They are significant feeding grounds, particularly along the Balochistan coast. The sources mention reports of 11 different whale species being cited. That includes 4 species of the large baleen whales, the filter feeders, and 7 species of toothed whales, like dolphins.
What makes it good feeding grounds?
It seems linked to seasonal upwelling along the Makran coast. Deep, nutrient-rich water comes to the surface, which fuels plankton blooms, including the tiny shrimp or krill that baleen whales feed on. So they come to these waters specifically to feed.
But within this group, there's one species, or subspecies rather, that's in extreme trouble, the Arabian humpback whale.
This is one of the most critical marine conservation concerns, not just for Pakistan, but for the entire Arabian Sea region. The Arabian humpback whale is now recognized as genetically distinct. It doesn't migrate long distances like other humpbacks. It seems to be a resident population, and it's listed as one of the most endangered whale populations on Earth.
How endangered? What are the numbers?
The estimates are truly alarming. The total population across its entire known range, which includes waters off Pakistan, India, Iran, Oman, Yemen, is thought to be only around 70 individuals. maybe fewer.
70 total, not just in Pakistan waters.
70 individuals total, that's the entire remaining population. It really underscores how incredibly vulnerable they are. Every single whale counts. Pakistan's waters are a part of their critical habitat, so what happens here has global implications for their survival.
What are the main threats they face in these waters?
Historically, like many large whales, they were targeted by whaling operations. But the threats today are different. Ship strikes are a major concern, especially in busy shipping lanes. Toxic contamination from pollution is another factor, but perhaps the biggest, most pervasive threat now is entanglement in fishing gear.
Bycatch again.
Yes, accidental entanglement in fishing nets, particularly large mesh gill nets set for tuna or other fish. It's often fatal for whales.
And what about dolphins? Are there specific local populations?
Yes, the sources highlight the Indian humpback dolphin. There's a small, apparently resident population estimated at maybe only 70 individuals again, found within the Miani Hor Lagoon system on the Balochistan coast.
Miani Hor, another ecologically sensitive area.
Exactly. And having such a small, localized population makes these dolphins incredibly vulnerable to any changes in their lagoon habitat, whether it's pollution, development, or fishing pressure. They're an important indicator species for the health of that coastal lagoon system.
Okay, moving from mammals to reptiles, sea turtles. We touched on this earlier, but Karachi's beaches, Sandspit, and Hawke's Bay are globally significant nesting sites.
Globally significant is right. They are recognized internationally as two of the 11 most important nesting beaches for sea turtles anywhere in the world, primarily for the green sea turtle. Thousands of female green turtles come ashore here to lay their eggs, typically between July and December each year. The sheer concentration of nesting activity makes these beaches vital conservation areas.
But like the whales, the turtles face serious threats. The sources link a decline in one species directly to a specific event.
Yes, the olive ridley turtle. Historically, they also nested in large numbers on these beaches, but their nesting populations reportedly declined significantly, and this is partly attributed to the major oil spill that occurred off the Karachi coast back in 2003. That event heavily contaminated nesting beaches and nearshore waters, impacting feeding grounds and nesting success for years.
And other critically endangered species use these waters too.
Yes, besides the green turtle, which is endangered, and the olive ridley, also endangered, though nesting decline is severe locally, two other species found in Pakistani waters are classified by the IUCN as critically endangered: the massive leatherback turtle and the hawksbill turtle, known for its beautiful shell. Astala Island, as we mentioned, is important for hawksbill nesting.
Let's talk about the scale of the fishing threat for turtles. The entanglement numbers are shocking.
They are horrifying. The estimate cited is that around 30,000 sea turtles get accidentally caught in fishing nets in Pakistani waters every year.
30,000 a year.
It's an enormous number. Now, there has been progress. Awareness campaigns involving fishermen have led to more turtles being released alive when caught. Training programs teach fishermen how to safely disentangle and release them. But even so, the stress of capture and the potential for injury, plus the sheer number caught, means incidental mortality in fisheries remains a primary driver of turtle population decline, alongside habitat loss and the threat of plastic pollution. Turtles often mistake plastic bags for jellyfish, ingest them, and die.
Finally, under the water, let's look at corals. Pakistan doesn't have those huge barrier reefs like Australia, but there are corals here.
That's correct. No extensive, true coral reef ecosystems like the Great Barrier Reef, but Pakistan does have documented occurrences of corals. The sources mention 29 species of both hard corals, the reef-billing types, and soft corals. They tend to occur in small, restricted patches.
Where are these patches found mainly?
The key locations mentioned are around Cherna Island, west of Karachi, and, again, Astala Island off the Balochistan coast. Astala is particularly interesting because there's evidence of what's called a proto-reef, basically, the very early stages of coral reef formation. It suggests that conditions there might be or might have been conducive to reef development.
We hear a lot globally about coral bleaching. Can you quickly explain what that is? It relates to a partnership, doesn't it?
Yes, it's all about a vital symbiotic relationship. The coral animal itself, the polyp, lives together with microscopic algae called zooxanthellae that live inside its tissues. These algae photosynthesize using sunlight, and they provide the coral with the vast majority of its food, maybe up to 90%. and also give the coral its vibrant colors.
Okay, a crucial partnership. So what is bleaching?
Bleaching is a stress response. When the water temperature gets too high, even by just 1 or 2 degrees Celsius for a prolonged period, or sometimes due to pollution or other stressors, this relationship breaks down. The coral polyp expels the zooxanthellae from its tissues.
It kicks out its food source and color.
Exactly. The coral tissue becomes transparent, revealing the white calcium carbonate skeleton underneath. That's why it looks bleached, or white.
Is a bleached coral dead?
Not necessarily immediately, but it's severely weakened, essentially starving, and much more vulnerable to disease and mortality. If the stressor, like high temperature, persists, the coral will likely die.
And what are the main local threats to these fragile coral patches in Pakistan?
Well, besides potential temperature stress, the big local threats are physical damage from fishing gear. Extensive gill netting in areas like Churna means nets get dragged over the bottom, breaking off and killing coral colonies. Discarded nets, known as ghost nets, can also smother corals. And sadly, there's also evidence of small-scale coral mining people actually breaking off corals to sell them for the aquarium trade in Karachi. And of course, general pollution from land doesn't help either.
This leads us directly into our next major theme, marine fisheries. It's critical because, as the sources state, fishing supports around 1 million livelihoods in Pakistan. It's economically vital, with shrimp being a key export.
Yeah.
But the methods, well, they seem fundamentally unsustainable.
They really highlight that conflict between short-term economic necessity for many people and the long-term health of the resource they depend on. The main fishing methods used are, first, gill netting. This is the most common walls of netting set in the water to entangle fish like sardines and tuna.
Okay.
Second is trawling. This involves dragging a large bag-shaped net, often weighted, across the seabed. It's mainly used to catch shrimp and other bottom-dwelling or demersal fish. And third, there's the seine net, locally called katra, which is used to encircle shoals of fish.
The sources use a really stark term for gill nets, the wall of death. Why such a dramatic description?
Because they are incredibly indiscriminate. While targeting certain fish, these vast nets accidentally catch and kill huge numbers of non-target species. Dolphins, whales, turtles, sharks, seabirds, as well as commercially unimportant fish. They just form these invisible walls in the ocean that trap almost anything that swings into them.
But the statistic that really jumps out, the one linked to shrimp trawling, it's almost unbelievable.
It is the single most shocking statistic in these sources regarding resource use. It's estimated that for every 1 kilogram of shrimp caught and landed by trawlers in Pakistan, approximately 95 kilograms of other marine life is also caught, killed, and then discarded back into the sea as bycatch.
95 kilos discarded for every 1 kilo kept. 95 to 1.
95 to 1. Let that sink in. It's an almost unimaginable ratio of waste.
What makes up that 95 kilos? What's being thrown away?
It's an absolute ecological tragedy being shoveled overboard. A huge proportion of that 95 kilos is juvenile fish, the young of commercially important species, like mackerel, sole, ribbonfish. So the fishery is literally killing off its own future supply before these fish can grow and reproduce.
Killing the babies, essentially.
Precisely. On top of that, the bycatch includes those endangered species we've talked about, thousands of sea turtles, dolphins, sharks, and it also scoops up vital benthic organisms, starfish, sea cucumbers, crabs, sponges, the creatures that live on the seabed and form the base of the food web. The trawls just scrape the bottom clean. The economic waste is staggering, but the biological damage is potentially irreversible.
And that's just the trawling. There's another specific type of gear mentioned as being particularly destructive in the nursery grounds, the estuaries, the estuarine set bag net, or bula.
Yes, the ESBN, or bula. This gear is described as devastating, particularly in the Indus Delta's creeks and estuaries, which are critical nursery areas for countless fish and shrimp species. It was apparently introduced by fishermen from Bangladesh.
How does it work?
It's basically a large bag-shaped net that's fixed in place, anchored across a tidal channel. As the tide flows in or out, water funnels through the net. The critical problem is the mesh size. It's incredibly small.
So it catches everything.
Pretty much everything larger than the mesh.
Mm.
Fish larvae, tiny post-larval shrimp, the smallest juvenile fish of dozens of commercially valuable species, they all get swept into the bag. It effectively strips these vital nursery grounds bare. The sources estimate around 8,000 of these bula nets are deployed just within the Indus estuarine system.
So when you combine the wall of death gill nets, the 95.1 bycatch from trawling, and these bula nets cleaning out the nurseries, it explains those earlier figures, doesn't it? 10,000 dolphins and 30,000 turtles killed annually.
It paints a picture of a fishery operating far beyond sustainable limits. It's directly undermining its own future viability while decimating protected wildlife. This obviously creates a massive challenge for management and policy. How do you regulate this when livelihoods depend on it, but the methods are so destructive?
Well, what is being done on the management side? Are there efforts to curb these practices?
There are measures, yes. On paper, the legislation looks quite strong. Both the provincial governments, Sindh and Balochistan, have officially banned the most destructive gears that includes trawling, the seine nets, katra, and those estuarine set bag nets, bula.
So trawling is banned, but the 95.1 bycatch figure suggests it's still happening.
That's the critical gap, isn't it? Bans are only as good as their enforcement. And the sheer scale of the fishing fleet, the vastness of the coastline, and likely resource constraints make effective enforcement incredibly difficult. The high bycatch rates strongly suggest that these banned gears are, unfortunately, still widely in use, either illegally or perhaps through loopholes.
Is there anything else? Technology, maybe?
Yes, there's a key piece of technology that's been mandated partly due to international pressure, particularly from the U.S. market. That's the Turtle Excluder Device, or TED.
KEDs. How do they work?
A TED is essentially a grid of bars fitted into the neck of a trawl net just before the final bag, the cod end, where the shrimp collect. Smaller animals like shrimp pass through the bars into the bag, but larger creatures like sea turtles or sharks bump against the grid and are directed out of the net through an escape hatch, like a trapdoor.
And this is required now.
It's mandated for shrimp trawlers, especially those whose catch might be exported to the U.S., as U.S. import laws require shrimp to be caught using TEDs to protect turtles. So there's a direct economic incentive for fishermen to install and use them correctly, although again, compliance and proper use remain ongoing issues.
And finally, trying to link sustainability with market value certification.
Yes, that's seen as a crucial market-based tool. There are active efforts underway to achieve Maritime Stewardship Council, or MSC, certification for some of Pakistan's major fisheries. The sources specifically mention the tuna troll fishery and the fishery for razor clams.
What does MSC certification do?
MSC is a global standard for sustainable fishing. If a fishery gets certified, its products can carry the blue MSC eco-label. This signals to consumers, particularly in environmentally conscious markets like Europe and North America, that the seafood comes from a well-managed, sustainable source. This can often command a higher price. So the idea is to create a financial incentive for fisheries to improve their practices, reduce bycatch, and manage stocks responsibly to gain access to these premium markets. It's a potentially powerful driver for change.
Okay, let's broaden our view now to the really big, overarching environmental threats that loom over this entire coastline. Starting with climate change. Pakistan is often cited as being extremely vulnerable.
It consistently ranks very high on global climate vulnerability indices. A 2014 report by Maplecroft, mentioned in the sources, placed Pakistan as the 16th most vulnerable country worldwide. And this isn't just a future threat. The impacts are already being observed along the coast right now.
What are the key indicators they're seeing?
Well, first, there's measurable sea level rise. Tide gauge data from Karachi Harbor shows an observed rise of about 1.1 millimeters per year. Now, that might sound tiny.
Yeah, 1.1 millimeters doesn't sound like much.
Per year, no. But compound that over decades, especially in the extremely low-lying Indus Delta region, and it leads to significant land loss, increased flooding, and saltwater intrusion into coastal aquifers. It's a gradual but relentless threat.
And what about extreme weather? Storms?
That's perhaps the more dramatic observed change. There's a marked increase in the frequency and intensity of extreme weather events, particularly tropical cyclones hitting the coast. The comparison is stark. In the 27 years between 1971 and 1998, not a single major tropical cyclone made landfall on Pakistan's coast.
None in 27 years.
Correct. Then, in just the 12 years that followed, from 1999 to 2010, 3 major destructive tropical cyclones hit the coast in 1999, 2007 Cyclone Yemen, and 2010 Cyclone Fet. This shift towards more frequent, powerful storms is a clear climate change signal for the region.
And looking ahead, the projections for the Indus River itself are deeply worrying, aren't they? Especially considering everything we've said about the delta and mangroves needing fresh water.
The future outlook for river flows is really concerning. The models predict that the retreat of the western Himalayan glaciers, which feed the Indus, is likely to cause a significant decrease in downstream river flows in the coming decades, potentially a 30% to 40% reduction.
30 to 40% less water in the Indus.
That's the projection. If that happens, the consequences for the Indus Delta would be catastrophic. The freshwater balance would likely collapse completely. Areas that are currently brackish would become fully marine, hypersaline even. The mangrove ecosystem would face immense stress, far worse than today. And the humanitarian crisis, driven by saltwater intrusion and land loss, already affecting nearly 1 million people due to the LBOD and reduced flows, would be massively amplified.
Okay, another major threat, coastal erosion. We know the main causes are that reduced sediment supply from the dammed Indus, plus mangrove destruction removing the natural shoreline binder. Where is erosion hitting hardest?
Erosion is a chronic problem along many parts of the coast. The sources mention Pesni, on the Mekran coast, as an example where its distinctive zeta-shaped sandy beaches are being noticeably worn away. But the most alarming land loss figures come, again, from the Indus Delta region.
Kiribundar and Kero-Chan.
Yes. In those two areas alone, it's estimated that around 9,065 hectares of land, that's over 90 square kilometers, have been permanently lost to the sea just since 1962. That's a huge chunk of territory, just gone, washed away.
When coastlines erode like this, the typical response is often hard engineering, building walls and structures. Why is that often not the best solution?
Hard engineering involves building things like concrete seawalls, rock groins, which are walls built perpendicular to the shore, or offshore breakwaters. They can provide immediate protection to the specific area right behind them, but they have major downsides.
Such as,
Well, they're incredibly expensive to build and maintain. They're often visually intrusive, destroying the natural beachscape. And crucially, they don't solve the erosion problem. They often just shift it. By blocking the natural movement of sand and altering wave patterns, a seawall in one location can accelerate erosion on the adjacent unprotected stretch of coast. They can also increase wave reflection, scouring the beach in front of the wall.
so what's the alternative? Soft engineering.
Exactly. Soft engineering techniques aim to work with natural processes rather than against them. This can include things like beach nourishment, basically, importing large quantities of sand to rebuild an eroded beach. It can involve creating or restoring natural defenses like salt marshes or, critically in Pakistan's case, mangrove forests, which dissipate wave energy and trap sediment.
But perhaps the simplest and maybe most effective approach in the long run is just planning better.
That's arguably the most critical intervention, especially for future development. Implementing effective coastal setback limits. Given that sea level rise and some degree of erosion are now inevitable due to climate change, the recommendation highlighted is that all new construction houses, roads, industries, infrastructure should be prohibited within a certain distance from the current high water mark.
How far back?
The suggestion mentioned is a minimum setback of 200 meters. This creates a buffer zone, allowing the coastline to shift naturally without immediately threatening human assets. It avoids locking communities into expensive and ultimately futile battles against the sea. It's proactive adaptation.
Finally, under threats, we have to confront coastal pollution. The sources paint a truly grim picture, calling it a health crisis. The main culprit seems to be untreated sewage.
Overwhelmingly, yes. Domestic sewage is identified as the single largest contributor to coastal pollution. The numbers are difficult to comprehend. An estimated 550 million gallons per day, MGD, of wastewater, mostly untreated or only partially treated, is discharged directly into the coastal waters, primarily from Karachi.
550 million gallons every day. How much is actually treated?
That's the shocking part. Karachi technically has 3 wastewater treatment plants, but their combined operational capacity is reported to be only around 55 mgd.
So only 10% gets treated.
Roughly 10–15% at best. That means 85–90% of the sewage from Pakistan's largest city, a megacity of over 15 million people, flows raw into the sea, often channeled through the Liari and Malir rivers, which essentially act as open sewers emptying into the harbor and nearby creeks.
And it's not just sewage, is it? Industrial waste too.
Karachi is also the nation's industrial heartland, and the sources state that around 90% of the industrial effluent generated by the factories in and around Karachi is also discharged, untreated into the sea, carrying heavy metals, chemicals, oils, and other toxic substances. This double whammy of raw sewage and untreated industrial waste has absolutely devastated marine life in the most polluted areas, like Manora Channel and Gizri Creek near the ports.
Ecologically, what happens when you dump that much nutrient-rich sewage, essentially fertilizer, into the ocean?
You get eutrophication. It's a classic pollution cascade. The excess nutrients, particularly nitrogen and phosphorus from the sewage, act like fertilizer for marine algae. This causes massive, rapid growth algal blooms.
Okay, lots of algae. What's the problem?
The problem comes when all that algae inevitably dies and sinks to the bottom. The process of decomposition carried out by bacteria consumes huge amounts of dissolved oxygen from the water. This leads to hypoxia, low oxygen, or even anoxia, no oxygen in the water, creating marine dead zones where fish, shellfish, and other organisms simply suffocate and die.
And the health impacts for humans.
Direct and severe. Bathing or fishing in waters contaminated with raw sewage exposes people to dangerous pathogens, leading to diseases like typhoid, cholera, dysentery, and hepatitis. Shellfish harvested from these areas can accumulate toxins and bacteria, poisoning consumers. And then there's the solid waste component. Plastics, especially plastic bags, washed into the sea pose a lethal threat to wildlife like turtles, who mistake them for food like jellyfish, ingest them, and starve or choke. It's a multifaceted crisis impacting both ecosystem health and human well-being.
Wow. Okay, so we've heard about unsustainable fishing, the 95.1 discard rate, devastating pollution like 550 mgd of raw sewage, habitat destruction, climate change impacts. It's clear that managing these problems sector by sector, fisheries doing one thing, ports another, environment agencies trying something else, it just isn't working. This brings us to the concept promoted in the sources. Integrated Coastal Management, or ICM. What exactly is that?
ICM is really a different way of thinking about coastal governance. It's defined as a dynamic, ongoing, and multidisciplinary process designed to promote the sustainable management and development of coastal zones. The idea really gained traction globally after the 1992 Rio Earth Summit, which recognized that coastal areas are complex systems where human activities and natural processes are intensely interconnected. You can't manage one part in isolation.
So the goal is to bring everything together. Ports, fishing, tourism, conservation, urban development.
Exactly. The core aim is to maximize the economic and social benefits that coastal resources can provide, while minimizing the conflicts between different users and minimizing the damage to the environment. It requires coordinating all the different sectors and stakeholders involved.
But the sources suggest that implementing this in Pakistan faces a pretty fundamental hurdle, the institutional setup.
That's highlighted as a major challenge. The current situation is often described as fragmented. You have a whole web of different institutions with responsibilities on the coast operating at different levels, local city governments like Karachi Metropolitan Corporation, provincial departments in both Sindh and Balochistan dealing with environment, forests, fisheries, etc., and powerful federal agencies like the Navy, the Maritime Security Agency, the Port Authorities, KPT, PQA, Gwadar Port Authority.
They don't always work together.
Often they don't. They operate in their own silos. This can lead to overlapping jurisdictions where it's unclear who is responsible for what. It can lead to conflicting sectoral interests, for example. A port authority wanting to expand might clash with the Environment Department wanting to protect a nearby mangrove patch. And ultimately, this fragmentation leads to inefficient decision-making, gaps in enforcement, and an inability to address these large interconnected problems holistically.
So if KPT wants to dredge a channel impacting fisheries, and the Sindh EPA has concerns, there's no single body to easily resolve that conflict based on an overall coastal plan.
That's often the problem. ICM tries to create mechanisms for that coordination. The specific objectives are usually threefold. First, to strengthen the management within each sector, better fisheries regulations, better pollution control, better port planning through improved legislation, training, and crucially, enforcement.
Okay, make each part work better.
Second, to actively conserve and protect coastal and marine biodiversity. This means preventing further habitat destruction, controlling overexploitation of resources, and identifying and safeguarding critical ecological areas.
Right.
And third, linking those two to promote sustainable utilization of coastal resources in a way that supports national development goals without undermining the ecological foundation for the long term.
A key part of that conservation objective within ICM is usually setting aside specific areas for protection, marine protected areas, or MPAs. Are there potential MPAs identified for Pakistan?
Yes, the sources mention that under a regional initiative called Mangroves for the Future, or MFF, several sites along Pakistan's coast were identified as high priorities for potential designation as MPAs due to their ecological significance.
Which sites are these?
The key ones highlighted are Churna Island, which we discussed as important for corals and as a feeding ground for whales and whale sharks. Miani Hor, that lagoon system vital for the resident population of Indian humpback dolphins. Astala Island, critical for turtle nesting, its endemic viper and the proto-reef. And Gwadar Bay, another large bay system on the Makran coast known for its biodiversity.
And what's the rationale for MPAs? How do they help beyond just protecting what's inside the boundary?
MPAs act as refuges. By protecting critical habitats like breeding grounds, nursery areas, and feeding spots from damaging activities like certain types of fishing or pollution, they allow marine populations within the MPA to recover and thrive. This can then have spillover benefits for areas outside the MPA as fish stocks replenish and larvae disperse. They also serve as vital reference sites for scientific research, helping us understand what a healthy coastal ecosystem looks like. They're a cornerstone of effective, integrated coastal management. You need these protected core areas to ensure the long-term resilience and productivity of the wider coastal environment.
So wrapping up this deep dive, it's clear that Pakistan's 990-kilometer coastline has this powerful, almost conflicting dual identity. On the one hand, it's undeniably the nation's strategic gateway to the world, home to bustling ports, driving global trade, centers of industry, absolutely vital economically.
Absolutely.
Yeah.
But on the other hand, it's this incredibly important yet fragile ecological shield. It harbors some of the world's most endangered marine mammals, like that tiny population of Arabian humpback whales. It provides sanctuary for globally significant turtle nesting beaches. Its mangroves protect the coast and nurture fisheries that support, as we heard, around 1 million people's livelihoods.
And we've seen throughout this discussion just how immense and interconnected the pressures are. It's not just one thing. It's the legacy of hydrological engineering gone wrong, like the LBOD,
Yeah.
displacing almost 1 million people through salinity. It's the daily onslaught of pollution, that staggering 550 million gallons of untreated sewage every day. It's the relentless pressure on marine life.
Particularly from unsustainable fishing practices. That 95-to-1 bycatch ratio in the shrimp fishery, it really stands out as a symbol of the crisis. The natural systems, the mangroves, the potential corals, the fish stocks themselves, they're simply being overwhelmed by this combination of pollution, habitat loss, overexploitation, and now the accelerating impacts of climate change.
If you had to synthesize all this, that 95-to-1 number feels like the ultimate indictment of the current way things are done, doesn't it? It encapsulates the unsustainability that runs through so many of these issues.
It really does. It's the starkest measure of waste and ecological destruction we've encountered in these sources. When 95 kilograms of marine life representing the future of the fishery, the food web, biodiversity is destroyed and discarded just to get 1 kilogram of shrimp, that stops being just an environmental problem. It becomes a direct existential threat to the long-term economic and physical survival of those 1 million people who depend on healthy marine resources. As you said earlier, the industry is, in effect, eating its own seed corn.
So let's end with a final thought for you, our listener, to take away from this deep dive. Something to connect this knowledge back to your own context. Given the scale of these challenges, the habitat destruction, the devastating bycatch epitomized by that 95-to-1 ratio, the urgent need for integrated solutions like ICM and marine protected areas, what responsibility do you feel you hold, even if you live hundreds of miles inland, for the stewardship of these coastal commons? Knowing that consumer choices shape markets, how might awareness of issues like this impact your decisions? Perhaps about the seafood you eat or the kind of policies you support regarding coastal management and conservation.
It connects directly to global goals like Sustainable Development Goal 14, life below water. Understanding the fragility and the immense value of this critical coastal system shouldn't just be academic. Ideally, it translates into a broader demand for responsible, integrated stewardship, ensuring that the economic potential of Pakistan's coastline can be realized without sacrificing the ecological systems that underpin its very existence and the survival of so many people.
That's a powerful note to end on. Thank you for guiding us through the complexities of Pakistan's coastline today. We hope this deep dive has provided the detail and context needed to think critically about this vital and vulnerable part of the world.